Assalamualaikum warahmatullahi wabarakatuh and a very good morning to all. So today, our group from RAS 1202K will be presenting about application of differentiation. What is that? Let's move on. So, before we start off this presentation, I would like to introduce you to our group members. First, you have Nurin Marsha Idina. Second, me, Nur Ainumila Inshira. Third, Nurul Amarina Alisha. And fourth, Nur Ira Maisara. So, without further ado, let's start off with the presentation.
So, this is an introduction. First, what is differentiation? Differentiation is a method used to find derivatives or rate of change of a function. It's also to determine the maximum and minimum values of certain functions. The rate of change of a function is defined as dy per dx is equal to fx equal to y. Differentiation have four techniques to solve, which is first, derivative of constant, linear and power of functions. Second, derivative of sums and difference. Third, product rules. And lastly, quotient rule. Next, there are 5 applications of differentiation. First, related rates. Second, maximum and minimum problems. Rolle's theorem and mean value theorem. Rolle's theorem states that if a function is a continuous on the closed interval ab and differentiable on the open interval ab such that fa equal to fb, then f prime x equal to 0. Whereas mean value theorem means there exists a point in the interval such that the tangent at the point C, which means FC, is parallel to the line that passes through the points A, FA, B, and FB. Next, relative extreme, first and second derivative. Last but not least, increase, decrease, and concavity. Now, what are the related rates? The rate of change usually with respect to time. Related rates problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. For example, dv over dt. dv is a rate of a change that needs to be found, while dt is a rate of change that has been known. The method that can be used to solve the problems, which is chain rules and implicit method. Method of chain rule usually used for finding the derivative of composite functions. For implicit method, sometimes functions are given not in the form of y equal to fx. The function given in a more complicated form, in which it is more difficult to express y in terms of x.
Next is problem statement. In this problem statement, it is stated that a hemisphere candy is first inflated by heat at a rate of 18 cm³ per second to achieve its shape. In this first sentence, we can know that 18 cm³ per second is the dv over dt, and it is a positive dv over dt because of the word inflated. Next, find rate of change of surface area when volume is 24 pi cm³. And in this sentence, it is to find dA over dt when volume is 24 pi cm³. And the hint given is the area of hemisphere, which is 3 pi r square, and the volume of hemisphere, which is 2 over 3 pi r cube.
Hi, my name is Nurin Marsha Idina. Let's continue the calculation. First step, we have to construct a mathematical equations. We have to find dA over dt. So the mathematical equation will be constructed as below. Step 2, substitute the info given into the equations. 80 cm equal dv over dt. So dA over dt equal dA over dv. Multiply with 18. Step 3, use the info from the area and the volume of hemisphere given. We can derive the functions using differentiations. So we will have dA over dr and dv over dr to substitute into the dA over dV.
Next is step 4. Step 4 is when you use the derived functions from previous step 3 to be substituted into dA over dV. This is because dA over dV is not the information that you get into the problem statement. So, you have to use the derived functions from previous step 3, which they derived from volume of hemisphere and area of hemisphere, because that is the information given. So in this step, you just have to write the function back, which is dA over dt equals to dA over dV multiplied by 18. So in this step, you have to substitute dA over dV with the derived functions you get from the previous step 3, which is in bracket dA over dr multiplied with dr over dV and multiplied by 18. Next, you have to substitute the value after you differentiate the derived functions, which is 6 pi r multiplied with 1 over 2 pi r squared and multiplied by 18. And then you have to calculate, and then you will have 3 over r multiplied with 18, and then you will get 54 over r. Next is step 5. As we all know, in the problem statement, it is stated that the volume is 24 pi. So in this step, we just have to substitute the 24 pi and equate it into the volume of hemisphere equation. So in this step 5, we can see in the slide, which is V equals to 2 over 3 pi r cubed, which is the volume of hemisphere. So we just have to substitute the V with 24 pi and equate it with 2 over 3 pi r cubed, which is the volume of hemisphere. And then we just have to calculate and simplify all the calculations, and we will get 336 equals to r cubed. And to eliminate the cube, we have to cube root both sides. And we will get this cube root of 36 is 3.3019, and that is the radius that we get. And lastly, step 6. Step 6 is the fast and simple way for you to get the rate of change of area, because you just have to substitute the r value that you get in step 5 into the function of dA over dt that you get in step 4. So basically, dA over dt equals to 54 over 3.3019, and you just have to calculate it. And lastly, you just have 16.35 centimeter squared for the area.
To sum up, by applying differentiation method into this problem, we can conclude that the application of differentiation used in this situation can be used to define a value of area, solve problem related to rate of change of area against time, can derive a new function from a general formula. And lastly, these are the references used throughout our discussion. That's all from us. Thank you and have a good day.